All right, in this lesson, we are going to talk about inverses again. But we are going to talk about inverses of exponentials and log/ln questions. First thing we need to remember, some background information, is that we talked about exponentials, which I'm going to abbreviate. So the exponential form and the logarithmic form, which I'm going to abbreviate, that they were actually opposite of each other. And if they're opposites of each other, then that means that they are indeed inverses. Okay. So these two things are inverses of each other. And then exponential form, in case you don't remember, is y equals b raised to the x. Log form is log base b of y equals x. Okay, let's get started. On the first one, you have to remember for inverses, you start by switching the location of the letters x and y. So you would say x equals log base 5 of y. Okay. Now, from here, the only way to get y by itself, to get rid of the log, is to rewrite it into the other form. So right now, this one is in log form, so your job is to rewrite it into exponential form. Okay, so exponential form, y. Well, y is the part that comes after log, which happens to be my letter y, equals b, which is your base, and our base is the number 5, raised to the x, which is letter x. Now, y is all by itself, so if y is all by itself, then technically you're done, but we would like you to put in your inverse notation. And remember, inverse notation is anything raised to the negative first. So I'm going to say y raised to the negative first equals 5 raised to the x. Okay. All right, next one. Start off by switching x and y. So x equals 8 raised to the y. Now this time, this one is in exponential form, so you want to rewrite it into log form. So log base, well, our base is the part attached with the exponent, so that would be the number 8. Y is actually our letter x, equals x, which is our letter y. And then you're going to notice y is by itself. Yay! So now we're just going to put in our inverse notation. So y to the negative first equals log base 8 of x. That's not a very good x. Let me erase that. And we're done. Okay, next one. We're going to start off by switching x and y. So x equals ln of y. And then we're going to rewrite. Now, log form, ln form, same thing. So we're going to go to exponential form. So exponential form, y is y equals base. The base for ln is always the letter e raised to the x. And then you're going to say y is by itself. So put in your inverse notation. Y to the negative first equals e raised to the x. Okay. Number 4. Start by switching x and y. So x equals ln of y. minus 4. Okay, don't try to move the minus 4. You're going to notice the minus 4 is inside the parentheses, which means it's grouped with that. So you can't move it until the parentheses is gone. And the only way to make the parentheses here go away is to rewrite it into exponential form. So for exponential form, we're going to go with y, which is our y minus 4, equals base. Base for ln is always the letter e, and then raised to the x. Now you want to solve for y, and to get y by itself, you have to move the minus 4. So when you move the minus 4, it becomes a plus 4. And then y is all by itself, so we'll put in our inverse notation. So the inverse is equal to e raised to the x plus 4. Done. Okay, so I'm going to scroll down. We got 4 more to talk about. All right, on 5. Start by switching x and y. So x equals log base 4 of y over 3. Okay. And we want to go ahead and rewrite this one into exponential form. So y is really y over 3 equals base, which is 4, raised to the x. Okay, now I have to actually do something else to get y by itself. So to get rid of the dividing by 3, I would multiply by 3. So then I get y equals 4 raised to the x times 3. Or if you want, you can also write it as 3 times 4 raised to the x. I'll just put my little inverse notation here. So it doesn't matter to me which one you put first. If you put the 4 raised to the x times 3, or if you say 3 times 4 raised to the x. All right, moving on. 6. Start by switching x and y. So x equals log base 2 of 8y. Then rewrite it into exponential form. So 8y equals base, which is 2, raised to the x. To get rid of the 8, we're going to divide it away. So y equals 2 raised to the x over 8. Now we do run into a small hiccup here. Here's what makes this problem difficult. On the top, you have 2 raised to an exponent. So you want to think on the bottom, is there a way to make it 2 raised to some power gives me 8? Okay, and hopefully you're thinking in your head, oh yeah, I know. 2 times 2 times 2 is 8. So you're really going to think of 8 as being 2 raised to the third. Now you can be like, ooh, I have the same base on top and bottom. So I get to remember my exponent rules. And my exponent rules says if I am dividing, I subtract my exponents. So then you're going to have y equals 2 raised to the x minus 3. And now I'll just put in my inverse notation and I am finished. So that one was a little tricky because you had to make your base numbers the same. Okay, 7. We're going to switch x and y. So x equals log base 4, parentheses 6y plus 1 minus 2. Now, this minus 2 is outside the parentheses. So since it's outside the parentheses, I can get rid of it. I can move it away. So to move it away, I'm going to add it over. So x plus 2 equals log base 4 of 6y plus 1. Now that we got the log parentheses part all by itself, then let's go ahead and rewrite it into exponential form. So y is 6y plus 1 equals base, which is 4, raised to the x, which is x plus 2. All right, so now let's work on getting y by itself. So to get rid of the plus 1, you should subtract it over. And then if we want to get rid of the 6 in front of the y, we're going to divide it away. So my inverse would be 4 raised to the x plus 2 plus 1 all over 6. Okay, last one. Start by switching x and y. So x equals 4 raised to the 3y plus 7 plus 9. All right, I want to get the exponent part by itself. So that plus 9 at the end, we need to get rid of that. And in order to get rid of that, I'm going to subtract it over. So x minus 9 equals 4 raised to the 3y plus 7. Now I can rewrite this one. And you're going to notice that finally we switched. This one is in exponential form. So I want you to write it into log form. So log, your base is 4. Y is x minus 9, and I'm going to put that in parentheses so it stays grouped together, equals x, which is 3y plus 7. Now all we have to do is get y by itself. So move the plus 7 over. And when you move the plus 7 over, you're going to subtract it. But here's the catch. You are not allowed to combine it with the minus 9 because the minus 9 is grouped in there with the x, and that 7 is not. And then here you're just going to get rid of the 3 in front of y by dividing it. So the inverse is log base 4 parentheses x minus 9, close my parentheses, minus 7 all over 3. And we are finished.